Hey everyone, welcome to my channel techbeast.org. In my last video, we discussed about what is Internet of Things, what is Web of Things, and how Web of Things is complementing Internet of Things. If you want to get a brief introduction about Internet of Things and Web of Things, please check out the link in the description. In today's video, we are going to discuss about widely used web protocols in Internet of Things applications, such as HTTP, WebSockets, and MQTT. So let's start with HTTP. HTTP stands for Hypertext Transfer Protocol. HTTP is perhaps the most popular application protocol used in the internet and in today's web in order to send and receive messages between various systems in the network. HTTP is an asymmetric request response client server protocol. So meaning the client will request for an information from the server and the server will respond with the requested information if it is available in the internet. HTTP is stateless. So meaning the server will not remember the previous request sent by the client. So all the requests sent by the client to the server is independent. Okay, so in the diagram you can see a client and a server. For example, the client is requesting for an information. So we are going to browse a website here. So the client is requesting for www.techbeast.org. Then the server is checking for this information in the internet. And once it finds this information, it's responding with a beautiful web page. That's how this HTTP protocol works in simple. This HTTP protocol always runs over TCP and IP. TCP is from the transport layer and IP is from the network layer of the OSI model. So let's talk in detail about HTTP over TCP IP in my next slide. HTTP over TCP IP. As I said before, HTTP runs over TCP IP in most of the scenario. The reason behind this is, let's say you are requesting for an information from the client to the server, or the server is responding to the client's request. There should be a packet delivery guarantee. Okay, so that's the main reason HTTP always runs over TCP IP, because TCP has a property. So the property of TCP is the TCP will provide an acknowledgement. Okay, so whereas UDP does not provide any acknowledgement. Okay, so TCP stands for Transmission Control Protocol, whereas IP stands for Internet Protocol. So TCP is used to provide a communication between two systems or two computers or two machines in the network, and IP is used to provide routing between these devices, and each device will be provided with the IP address in order to identify and send the data and packets between these devices. Okay, so TCP IP is a transport and network layer protocol used to communicate between two machines using the IP address. You can send and receive messages. Okay, so you from the diagram below you can see IP is on the layer 3 and TCP is on the layer 4, whereas HTTP is running over the TCP IP. Okay, so let's see how this HTTP works in Internet of Things. Before I talk about how this HTTP works in Internet of Things, I want to introduce a new term called REST. REST stands for Representational State Transfer. So basically REST is a standard, or you can consider it as a design, okay, to communicate between systems on the web. Whereas HTTP is a implementation based on REST standard. Okay, so REST is a standard or design, and HTTP is an implementation following that standard. Okay, so if any architecture in the web follows REST standards, it is said to be RESTful. Okay, by default. If a device is working based on this standard, means in order to access the device should provide a REST API. So API means application programming interface. Basically, it's a set of rules in order to make programs talk to each other, or you can say web services talk to each other. Okay, okay. So let's take an example here. So I have a client. It can be any of your smartphones or your laptops or browsers, whatever. So, and I have a smart bulb which supports HTTP, and it's running a web server inside. Okay, and the device provide a REST API which supports get, put, and delete. So what is this get, put, and delete? So basically these are all the HTTP verbs we call. So when you're searching for a website in from your browser, by default you are making a get request. Okay, that's how this HTTP works in normal scenario. But when it comes to REST API, there are some other HTTP verbs we will have the option to use. For example, put and delete. So put, you when you will use this in order to change the state of a bulb, you can use put request. And if you want to remove this device, or if you want to delete this device from the server, you can use a delete request. Okay, so now I have a client, I have a smart bulb supporting this HTTP protocol, providing a REST API. I'm going to make a put request. For example, the web server inside the smart bulb is accessible over http colon slash slash the webserver.com slash bulb slash properties slash on. Okay, so I'm going to make a put request to this http endpoint, and the bulb will turn on once I make, and the server will respond with some kind of status code, as I said, 200. Okay, okay, this is the acknowledgement the server will make to the client. Okay, so I received your request, I have turned on. So okay, 200. Okay, so it's saying I'm fine now. Okay, so that's how this HTTP works in Internet of Things. So basically it can be anything. You can, let's say you have a smart sensor, you have any kind of IoT devices. Each device will support some kind of HTTP verbs, get, put, post, delete, so anything. So basically how this is how the HTTP works in Internet of Things. Okay, now let's talk about WebSocket. So what is a WebSocket? So WebSocket is a communication protocol providing full duplex communication between the client and the server over a single TCP IP connection. Okay, so how WebSocket is different from HTTP? HTTP is unidirectional, meaning the client will send a request to the server in one direction, and the server will respond to the client in the another direction. So basically it's just unidirectional. But in WebSocket scenario, both your client and server will establish a full duplex communication, and the connection between the client and server will always remain open as long as the client or server explicitly close it. Okay, so WebSocket is also an application layer protocol located at layer 7 in the OSI model, and it depends on the transmission control protocol at layer 4. Okay, so today the most of the modern browsers which we are using, like Firefox, Chrome, everything supports this WebSocket. So basically WebSocket is one of the HTML5 standard. Okay, so a lot of web applications today support WebSocket, and there are wide range of IoT applications or under development using this WebSocket. So let's see. So here you can see, so basically the client and server is a bidirectional communication between the client and server using a single TCP IP connection in order to send and receive messages. So now let's see how this WebSocket works in Internet of Things. Okay, I have a client, so it can be anything, as I said, your smartphone or browser, and I have a smart bulb supporting WebSocket now. Okay, so basically how this WebSocket works is the client will always do a handshake with this server first. So for example, it's going to use a HTTP GET request by mentioning that upgrade my connection to WebSocket. Okay, once the server receive this request from the client, it will respond with 101. I'm switching the protocol to WebSocket. Okay, so now the smart bulb and the client will have a full duplex connection. So meaning the client can send anything to the smart bulb, and the smart bulb can send anything or all its information to the client in real time. Okay, so that's how this WebSocket works. So you should always make a handshake with the server first. If the if the server supports, or if the smart bulb supports WebSocket, it will respond with 101 status code. If it does not support, it will still run on the HTTP. You can access it over a REST API if it supports. Okay, so if any of the client or server want to close the connection, they can close the connection of this WebSocket. Okay, so that's how simple the WebSocket is. So we can use it for a lot of real-time applications. And why we need to use WebSocket? So WebSocket is basically an internet standard, and it's one of the commonly and widely used web technologies in modern web browsers nowadays. Okay, so WebSockets are not blocked by firewall and can traverse proxies. So meaning WebSocket always complements HTTP. So it can run on a port 80 or port 443 in order to provide a secured WebSocket. Okay, WebSocket is useful for real-time communications without any delay in IoT applications. So you can always use if you want to sensor data, you to show it on your dashboard, you can always use a WebSocket connection in order to send real-time information. Okay, then WebSocket use very less bandwidth than HTTP. Okay, whenever the HTTP you are making a request to the server, there are you are going to make some kind of high bandwidth in order to make a request and get response. But WebSocket, since the connection is always open, the bandwidth requirement is very minimum than HTTP, and of course WebSocket is faster than HTTP. Okay, so these are all the advantages of using WebSocket over HTTP. But if battery based devices if you're having means, it's always good to use HTTP, because WebSocket you are going to make a connection between a client and server always open, which will drain the battery very fast. Okay, now let's talk about MQTT. MQTT stands for Message Queuing Telemetry Transport. So I can strongly say this is one of the trendy protocol used by a lot of companies or developers around the world. Okay, for IoT based applications. So basically, what is MQTT? So MQTT is an application rail protocol similar to HTTP and WebSocket, located at layer 7 in OSI model, which works on publish subscribe concept. So in WebSocket and HTTP, we call it request response, but here it is a publish subscribe concept. Okay, so it runs on the top of a TCP/IP, similar to HTTP and WebSocket. Here there will be a mediator we use, okay, we will use to communicate, or to send data between your sensor and your client device or whatever. So we call it a broker. Okay, so we always use a broker in order to send and receive data. So the broker can either be in local or in the internet. Let's say if you want to communicate locally, okay, you can use a local broker. Or let's say you want to communicate with internet, your device is somewhere and you want to access it somewhere from the world, so you can use your broker available on the internet. There are a lot of public brokers like Hive, Mosquito also is a local broker. So a lot of brokers are available, open source brokers are available, which you can make use of. And one of the key feature of this MQTT is this MQTT offers a quality of service. Okay, so basically the MQTT offers 3 level of QoS. So what does it mean? So QoS 0, QoS 1, QoS 2. So QoS 0 means it's just fire and forget. So meaning whatever the messages you published, okay, there won't be any delivery guarantee. So whether the subscriber may get your message or may not. So there won't be any guarantee for your messages. QoS1 means deliver at least once. Okay, so for example, the published messages will be delivered to the subscriber at least once. QoS2 meaning deliver exactly once. So the published messages will be delivered exactly once to the subscribers. So whoever subscribe to this particular topic, the message will be delivered exactly once. Okay, so this is one of the key feature offered by MQTT. So basically this MQTT will publish and subscribe via uh, uh, some kind of parameters called, we call it topics. Okay, so basically all the information or all the sensor data whatever we will publish on a topic. The subscriber will subscribe to this topic in order to read the data. Okay, so maybe let's take a look into a real life example. So now let's see how this MQTT works in the Internet of Things scenario. Okay, let's say you own a smart car or an autonomous car, which is having a lot of sensors like radar sensors, laser sensors, ultrasonic sensors. Okay, and you're planning to use MQTT in order to monitor the performance of the car, and you want to get the data in real time, and you want to monitor it in a dashboard. Okay, so now you're going to use a public broker which is available on the internet, and what you're going to do is you are going to publish your sensor data to this broker. So in this MQTT scenario, your smart car and your client device both are clients, and your broker is a server. Okay, so your smart car will publish the sensor data to the broker on the topic sensors slash radar, which publish the radar data, and sensors slash ultrasonic, which publish the ultrasonic sensors data. And you are using your client device in order to subscribe to this particular topic. So subscribe sensor slash radar, subscribe sensor slash ultrasonic. Once you subscribe, the broker will publish the information to you. So sensor slash ultrasonic publish, sensor slash radar publish. So you can able to read this data sent by the smart card. So basically this publish and subscribe, it's happening through TCP IP. Okay, so that's how this MQTT works in a real world scenario. So the smart card and the broker, so meaning the client and the server, will always try to remain or try to keep its connection open as long as possible. Okay, the smart card will always send a frequent ping request to the broker in order to ensure that the connection is always open, to ensure the quality of service. So that's how this MQTT works. And now, why MQTT? Why I need to use MQTT? So let's take an example, like you own a farmland and you want to monitor your farmland by deploying some sensors around the farmland. Okay, so and there is no proper network connection there because farmlands will be somewhere around the corner and there won't be any proper network connection there. So you can use MQTT protocol under such scenario. Okay, so MQTT is mainly used for constrained devices with a limited bandwidth or a limited battery, so those kind of devices. So MQTT always uses less battery power to publish and subscribe data. Okay, and as you can see, the connection is always secured using TLS. So meaning the publish and subscribe data is always encrypted over the web. Okay, and MQTT has a wide range of applications, and that's the reason MQTT is widely adapted in a lot of IoT application nowadays. Okay, so I hope you guys enjoyed this session, and I hope you guys understood what is the difference between various IoT protocols like HTTP, MQTT, and WebSocket. And I hope you can confidently choose your protocols based on your needs, and you can build your IoT applications. Okay, so thanks guys, thanks for watching. So your comments are welcome. So every day I'm trying to improve myself, so whatever your thoughts, you can just uh, put it in YouTube comments, and please subscribe to the channel, and I will be making a lot of new videos, and we'll be talking more about open source cloud, and a lot of tracks are on the way. So let's make technology easy peasy for everyone, and have a good day.